All right. So again, we started this on Friday with factoring by a greatest common monomial factor. Now we're looking at binomial. So a common binomial. So it's still a GCF, but instead of a monomial or a one-term polynomial, we're going to do a binomial or a two-term polynomial. Now, this method is also called factoring by grouping. Now, with factoring by grouping, you typically only do this method if you are given four terms. So basically, a polynomial that has four or more terms. It's typically just going to be a four term. What the heck? All right, so let's look at this first example. Now, these examples right here are typically what you want to get your grouping method down to. All right, so with factoring by grouping, these examples are basically what you want your factoring example to get down to, but it takes a little bit of work. Now, if we were to factor by a GCF, all right, what do you think the GCF of number 9 would be? And it is a binomial. So what do both of these two terms have in common? They have the what? I heard it. They have that x plus 9 in common. That's their GCF in this case. So remember, if they're in parentheses, they're married. All right, you can't break them apart. So my GCF in this case would be x plus 9. So that's my first factor, x plus 9. Now, if I divide both of these terms by x plus 9, and they're both in parentheses, what happens? Don't these two x plus 9s cancel out? Guys, heads up. We're not sleeping today. Come on. Up, up, up. Don't these two x plus 9s cancel out on both sides? Yep. So what am I left with as my second factor? So 6x, and then what's the other part? Minus 4. So that's what I'm left with. I'm with the 6x and the minus 4, and we put them together. Now, a trick that you will learn with factoring by grouping is that when you factor by grouping, you want what's in the parentheses to be the same. Because once you have them the same, the trick is that you bring one of those parentheses down, and then you take whatever the two GCFs of those outside those parentheses down into their own bubble. So 7f minus 2. And then just like that, it's factored. So you can either use the GCF method, but I think this trick is a little bit easier. You just got to remember to take one of the bubbles down, if they're the same, and then bring the two GCFs, which these are technically monomial GCFs, down into its own bubble. So if I use that method for number 11, first off, my two sets of parentheses are the exact same binomial. All right. So if I do the method I just did with number 10, what will my answer be? So remember, bring one of the bubbles down. So you know one of your factors is going to be n minus 5. Because we brought one of the bubbles down. What would the other factor be? 3n plus 8. You bring the other two monomials into their own bubble. What about this last one? First off, what's the unspoken value that this minus is right here? It's a -1. So keep that in mind. All right. What's my first factor if I brought one of those bubbles down? It's z minus 8. Then if I bring these two down, what do I get? nz minus 1. So don't be thrown if you just see a minus here. That just means you put a 1 in front of it. That's all you do. Now, the reason we did this is because this is one of the last steps that we do when we factor by grouping. Now, when we factor by grouping, all right, and you may want to write this off to the side or you can write it below if you have room, but here's the steps for factoring by grouping. So, the first step to factoring by grouping is to group two terms together. So in the end, you should have two groups of 2. The second is to find the GCF, just the normal GCF like we've been doing on Friday, of each individual group. So the two groups are separate. You find the GCF of each. And then the last step is to bring down one of the bubbles, so one of the parentheses, and make a note that they must be the same binomial in order to do it. If not, you did something wrong. That's like a check method with GCF. And then bring down the two GCFs in their own bubble. So sometimes I call those sets of parentheses bubbles. So if you hear me say bubble, that's what I mean. All right. If those steps don't make sense to you, don't worry. You'll see it in an example. So guys, heads off that desk. Come on. All right. So now let's try some examples. So look at number 13. So again, like I said, grouping is typically done with 4-term polynomials. All right. What I like to do when I group is that the first 2 terms I group together and the second 2 terms I group together. So I'm just going to draw a big line between the second and third term. So the left side is my first group. So this is my first group. And the right side is my second group. Now, since we drew that line between them, they are now separated from each other. All right. So now we're going to find the GCFs of both individual groups. So for my first group, what do you think my GCF is? You can draw the factor tree if you want, but take a minute, figure out what the GCF of the first group is. So everyone needs to try and figure it out because I'm going to start drawing popsicle sticks. So do a factor tree for the first group, figure out what the GCF is. I'm not doing it for you. So I just want to know the GCF of the first group. So 3y cubed minus 12y squared. That's all I want to know. All right, Kyrie, what's the GCF of this first group? Right. So that GCF is 3y squared. So I can divide both sides by 3y squared. So that's my first factor. Now, if you did your factor trees, what do you have left over? So the first one would be so guys, look at your factor trees if you drew them. What's the only thing left over after you take out 3y squared from 3y cubed? It's a y. Then minus 12y squared divided by 3y squared. What do you have left? Not just a 2, you also have a... Do you have two 2's left over? What's 2 times 2? 4. If you do y squared divided by y squared, that cancels out. 12 divided by 3 is 4. So that's your first group. Now, the GCF for the second is really obvious. What's the GCF? Not 2y, just 2. Because the 8 doesn't have a y, right? So the GCF for this one's just 2. So if I divide both these terms by 2, so 2's on the outside. What's 2y divided by 2? What happens to these two 2's? They cancel each other out. So what are you left with? Y. What's negative 8 divided by 2? Negative 4. All right. So now we got our two groups. Now we got to make sure that our two bubbles match. Do these two bubbles match? Yes or no? Yes. Since they do, we did this part correctly. Now we're going to do what we did with the previous examples. So we're going to bring them all together. So I'm going to bring down my two GCFs into one bubble. So this will be what? If I bring down the two GCFs? 3y squared plus 2. That's my first factor. And then I bring down one of my bubbles. It doesn't matter which one because they're the exact same, which would be y minus 4. And then we're done. Now, if I wanted to check myself, what could I do? What does this form look like to you? Something we've already learned. It looks like a what type of problem? Not quotient, but what did we do pretty much all last week? We were doing a lot of what operation with polynomials? I'll give you a hint. Box and FOIL. What do we use those two methods for? Multiplying, right? You could multiply these back, check to see if you get what you started with. All right, that's how you can check. Let's try this one. So first step, I make my two groups. So I'm drawing my line. So if it helps, you can also put parentheses around these. So this is the first group. This is the second group. All right. What do you think my GCF is of my first group? Yeah. So if it helps, break it apart into the constants and the variables. So, Addie, what do you think the 10 and the 25 have in common, GCF wise? What factors do they definitely have in common? 5. So that would be the first part. All right. Now, Neely, p cubed and p squared. They both have at least how many p's in them? So p cubed and p squared. Between the two of them, how many p's do each of them at least have? 2. So if we have p times p or 2 p's, that would be equal to what? P squared. So that's our GCF. That's another strategy you can do if you don't want to do the factor tree. All right. So that's our GCF. So now we're going to divide both of those terms by 5p squared. So we're going to have 5p squared on the outside. If I do 10p cubed divided by 5p squared, 10 divided by 5 is what? 2. What's p cubed divided by p squared? Just p. So you're left with one singular p. Now, what's negative 25 divided by 5? Negative 5. Good. So negative 5. And then what's p squared divided by p squared? So think about it. You're dividing something by itself. So that is 1. So we don't write any p's. The p's cancel out. So there's our first factored group. Now the second one. Let's go with Ben. What's the GCF of 4p minus 10? So what number could you use to multiply to another number to get 4 and 10?
2.
So it would be 2. So if I divide both terms by 2, we have 2 on the outside. 4p divided by 2 is 2p. Negative 10 divided by 2 is negative 5. Now, we got to check to make sure our bubbles are consistent. Are they the same? Yes, so we know we did it right. So what do you think my answer is if I do the bring down method? Lissandro.
4p squared plus 2.
5p squared plus 2.
And then 2p minus 5.
Good. So what he did, he brought down the two GCFs into their own bubble and brought down a singular one of the other bubbles. So this is our answer. Because essentially what factoring by grouping is that we're finding the binomial GCF, which in this case, the binomial GCF is what? 2p minus 5. They both have that in common. So it's almost like we're factoring out a binomial GCF. That's what factoring by grouping can be thought of as. All right. Any questions on number 14? Now, you need to get pretty decent at grouping because when we get to factoring trinomials, you will see it again. All right. So if you have questions on it now, please ask. All right. Let's look at number 16 together. No. All right. So with number 16, we first group our terms together. So I'm going to draw the line down between the second and third term. Now, I want to keep the sign with the third term because if you'll see in a second. But if you ever have a negative sign in front of that third term, make sure it stays with that third term. All right, so just get in the habit of drawing this third term sign with the third term. So these are my two groupings. All right, so with the first group, you can either do a factor tree or you can just look at it one term at a time. What do you think the GCF is of 15 and 40, James? So just 15 and 40. What do you think the GCF would be? Think about it. What number could you definitely divide evenly into both numbers? 5. So that would be the first part of the GCF. Now, the r cubed and r squared, what would be the GCF of that? Let's go. Riley M. So r cubed and r squared, what do they both have in common? How many r's do they both have in common? 2. So 2 r's would be written as what? R squared. Good. So that's the GCF of the first one. So if we divide both of these terms by 5r squared, all right, we got 5r squared out here. What's 15 divided by 5? 3. What's r cubed divided by r squared? How many r's would you be left with? 1. All right. What's 40 divided by 5? 8. And r squared divided by r squared? How many r's would you be left with? None, right? So that cancels out. So that's the GCF of our first group. Now, think carefully about this. If you were to eyeball the second group, is there a GCF at all? No. Now, we can't say that it's nothing because we still need some type of GCF to pull out to make this work. So if there is not a GCF, that means the only thing that those two terms have in common is a GCF of 1. Because it goes evenly into both. So if you ever don't have a GCF, the GCF is 1. All right, do not leave it out. If there's no GCF, do not leave it out. The GCF is 1. So we would rewrite this as 1 times 3r plus 8. Because anything divided by 1 is just itself. So we would divide both terms by 1. And again, anything divided by 1 is just itself. But we still need to have a written down GCF. All right. Now, our bubbles are clearly the same. So what would my final answer be if I bring everything down? Someone who hasn't talked yet today. So Riley E, what do you think my answer would be? Or at least what would my first bubble be? So 5r squared plus 1. If you bring down the two GCFs, what's the other bubble? 3r plus 8. Good. So again, it would not just be 5r times 3r plus 8. You got to have that second GCF. So if there ever is not a GCF of one of the groups, its quote unquote GCF is just 1. So you need to write it as such. And that's honestly one of the most common mistakes I see with factoring by GCF. All right, any questions on this? All right, so for the rest of class, you guys got a solid 35 minutes. You can work on the 7.3 Delta Math as well as the packet work. I believe the packet work is page 6, I think, off the top of my head. But there is a Delta Math already posted. It covers both GCF as well as grouping. It shouldn't be too long, though. Yes. Yeah. All right, so go ahead and